Dear students, today in this topic we are going to discuss about capacitance of parallel plate capacitor with a conducting slab. As we know, capacitor is a device which is used to store the charge. So in this topic we will discuss what will happen if we placed a conducting slab between the parallel plate capacitor. So to understand this, let us consider we have two plates of capacitor. So we have two plates of capacitor. First one is, let us consider we have plate A and the other plate is B. Let us suppose the charge on the plate A is positive charge. Similarly, the charge on plate B is negative charge. So because of this negative and positive charge, a field is developed between the plates of capacitor, and the distance between the two plates of the capacitor is D, and the area of the capacitor plate is A. Area is equal to A. So now what we will do, let us insert a conducting slab between the two plates of the capacitor. So this is your conducting slab between which conduct electricity. So what will happen? Which changes will occur due to this conducting slab? As we know, in the conductor there are atoms and molecules. So we have a positive charge on the capacitor slab. So due to this positive charge, a negative charge is generated on the conducting slab. Same thing happen on the B. B is a negative charge. So because of that, positive charge feel attraction towards negative plates of the capacitor. Because of this, the charges are induced inside the conducting slab. As we know, the electric field inside the conductor is 0. So we can see here there are equal number of negative and positive charge here. So we can say here inside the conducting slab E is equal to 0. Now the next thing is, what will happen? Electric field which is generated due to the positive and the negative plates of the capacitor. So let us consider the field produced by the positive and negative plate of the capacitor is represented by the red color arrow. This is the original field due to the plates of the capacitor. So we can give the name to this field is E0, and in this region also the field is E0. So E0 field is in this region and this region, and between this region electric field is equal to 0. There is a no field between the conducting slab. So in this region where red arrows are there, so what is the length of this red arrow region? This portion and this portion, the length we have to find. Let us consider the thickness of conducting slab is T. So now we have to find what is the thickness of this and this region. So we will subtract T from this D. So thickness of this red region is D minus T. This green color region, this green color portion region, or you can say red color region thickness is D minus T. So in the next part we will find the potential difference between the two parallel plates of capacitor. We know the potential gradient formula, there is a relation between electric field and potential gradient. So E is equal to dV by dr. So we can rearrange this expression and we will get dV is equal to E dr. Now using this formula we will find the potential difference for two plates. Let us consider V is the potential between two plates. Basically we are finding the potential difference to find the capacitance. So potential difference we can write for the region. Electric field is present in this region and this region where the red arrows are there. The field value in the red arrows is E naught. And the thickness of this region is D minus T. Thickness of this and this portion is D minus T. So the length of the red arrow is D minus T. So in the next step we will substitute the value of electric field. If you remember your previous chapter, we derived the formula for electric field between two parallel plates of capacitor. The formula is sigma by epsilon naught. And we also know sigma is equal to Q by A. So we are using these two formula and substitute the values in equation 1. So E naught is equal to sigma by epsilon naught, and this one is your D minus T as it is. In the next step, substitute the value of sigma. The value of sigma is Q by A. So this is your next equation. So basically we have to find the capacitance. So capacitance of a parallel plate capacitor. So we have one formula, capacitance C equal to Q by V. Substitute the value of V in equation number 3. Put 2 in equation 3. Basically you have to substitute the value of V in third equation. So after substituting the value of V, you will get this equation. Q and Q will cancel out each other. So here epsilon naught you have to write from the equation 2. So finally you will get epsilon naught A D minus T. In the next step we will take out D common. You will get D 1 minus T by D. And if you remember in the first chapter, capacitance of parallel plate capacitor is epsilon naught A by D. You can take it as equation star. If you compare these two equations, you will get, so when there is a vacuum between two plates, this is the formula equation and star. So now substitute the value of C naught in the previous equation. 1 minus T by D you will get as it is. So this is your final expression for capacitance of a parallel plate capacitor with conducting slab. From this expression you can see C is greater than C naught. In the equation star, the equation star is the equation which is applicable for vacuum. Okay, so the next equation is for when conducting slab is inserted there. So out of these two, you can see easily from here, in the denominator something is going to the subtract, and you can compare this equation with equation star. So in this denominator one term is going to subtract. Because of that, because denominator is less now, so because of that your C will increase, because both are reciprocal to each other. So that's why when you inserted a conducting slab, capacitance of a parallel plate increases always. You can compare the denominator of the C naught and C. You will get C is greater than C naught, and here overall denominator is decrease and C will increase, and vice versa. And I hope this topic is clear to you. So basic thing which we have derived here, capacitance of parallel plate increases when you inserted a conducting slab between the two plates of capacitor, and overall capacity will increase after insertion. What will happen if thickness of this plate T is equal to D? When thickness of plate T is equal to D, then substitute the value of T is equal to D, you will get 0, and something divided by 0 is equal to infinite. So thickness of parallel plate capacitor and conducting slab is equal, then capacity becomes infinite. So that's all for today, and if you like my video, so please subscribe my channel, and if you have any query you can comment below the video. Thank you.